Okay, so we're getting into what are called combinations and permutations. Okay, so let's take a look at what's going on here. We have a thing called the fundamental counting rule. And this is pretty straightforward. It says that if I have a sequence of two events, and the first one can happen m ways, and the second one can happen n ways, then the number of ways that these two events can occur is m times n. So like, if I flip a coin, it can happen 2 ways. If I roll a die, it can happen 6 ways, which means the possible outcomes from flipping one coin and rolling one die is 2 times 6 or 12 ways. So that's a pretty simple idea, right? So in this case, we have basically events where the events happen in sequence, right? So there's an order to them, and then it kind of goes from there. All right, so this is going to have us have to introduce a mathematical construct. So this is going to be something that we're going to call the factorial. Okay, so the factorial, which is written as some number exclamation point, is defined the following way. 0 factorial is going to be 1. 1 factorial is also 1. For numbers bigger than 1, n factorial is going to equal n minus 1 factorial times n. Okay, so let's try to understand what this means. Basically, you just keep counting backwards. So like if I have 4 factorial, 4 factorial should equal 4 times 3 factorial. But 3 factorial is 3 times 2 factorial, which is 2 times 1 factorial, which is 1. So, so that's what happens here. 4 factorial is just 4 times 3 times 2 times 1. 6 factorial would be 6 times 5 times 4 times 3 times 2 times 1. Okay, so let's see. 4 times 3 is 12. 12 times 2 is 24. Times 1 is 1. Or times 1 is 24. So 4 factorial comes out as 24. Okay, so this is a pretty simple idea. Okay, so we get a factorial rule. Which says that a collection of n objects, so if I have n objects, can be ordered, oops, yeah, spelling, A-J-E-C-T, there we go, can be ordered n factorial ways, right? So like if I had 4 objects, there would be 24 different ways that I could order those objects. So this gets me an idea of a factorial. But here I have to order all the objects, right? Well, what if I only want to like order some of them? Like let's say I want to pick 3 objects at random out of my set of 4, and then I want to see how many different ways can I order those 3 objects, right? So this is what we're going to call a permutation. Okay, so we're going to get a permutation rule. Essentially what's happening here is I have n objects. And I'm going to choose r of them and put them in order. Okay, and we have a formula for this. We say that NPR, so that's taking a permutation of size r from a set of size n, is n factorial over n minus r factorial. Okay, so let's say I had 5 objects and I want to choose a a pair of them, and I want to know how many different ways can that happen. How many different orderings of 2 objects can I get out of 5? So that's 5 factorial over 5 minus 2 factorial, right? So this is 5 times 4 times 3 times 2 times 1 over 5 minus 2, so that's 3 factorial, right? So that's 3 times 2 times 1. That cancels with that. Leaves me with 20 different ways of doing this. Now, that seems like a lot of complicated stuff. So we're actually going to bring out the calculator here and show you that your calculator can do both factorials and ultimately calculate permutations for you. Okay, so here I have my TI-84 calculator. Let's say I want to calculate 4 factorial. So I hit 4, and then I hit math, and I'm doing something that's actually under probability here. And if you look down here under number 4 is the factorial option. And if I hit that, it tells me, aha, that's the same as 4 times 3 times 2 times 1, which is 24. So that's like great step forward. So like what I could have done is said, what's 5 factorial divided by 5 minus 2 factorial, and the calculator gave me that 20 that I got in my example of like choosing 2 objects out of 5 and then putting them in order. But what's even better here is the calculator can do all of that in one step. I'm going to choose 5, and then I go math, back to probability. If you look at option number 2 there, that's the permutations option. So that's my NPR 5, permute 2, and lo and behold, it comes back with 20. Okay, so we got one last thing to do here. Permutations order matters. Combinations are something where order is not going to matter. We're going to look at those in a second here. Okay, so this is going to give me a combination rule. Okay, so with combinations, I still have n objects. And I'm just asking how many ways can I choose r of them, okay? Now, in this case, I don't care about putting these r objects in order. I just care how many different ways can I choose r objects out of n, not how many different ways can I order r objects. So let's have a formula for this. It's NCR, which is n factorial. And again, it's n minus r factorial. But then I would put another r factorial down here. Okay, so let's say I have 5 objects, and how many different ways can I choose 2? So that's 5 factorial over, let's see, 5 minus 2 factorial times 2 factorial, right? So that's 5 factorial over 3 factorial times 2 factorial, which is 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times 2 times 1, because 2 factorial is 2 times 1, right? So this is going to cancel with that. That's going to give me 20 over 2, which is 10 different ways I can choose 2 objects from a set of 5. Now, I don't care about the order that they come up in. It's just how many different ways can I choose 10 objects from a set of 5. So combinations are always smaller than permutations. Now, it would be awesome if I could do this also with my calculator. Okay, so I want to choose 2 objects out of 5, and I don't care about the order. So we're going to go 5, math, I go to permute, and I go to option number 3. There's the NCR. Okay, so we go to number 2. So we're going to choose 2 objects out of 5, and it tells me, lo and behold, there's 10 ways to do that. So it's doing all the work for me. I don't have to do any of the heavy lifting here. All right, so let's kind of build a little table to summarize what we've said here. Okay, so when it comes to counting, we have a couple of different situations here. We have a situation where order matters, not order. And order doesn't matter. We have a situation where we have without replacement. And we have a situation with replacement. Okay, so if I'm without replacement, I can only choose each object once. If I am with replacement, I can keep choosing the same object over and over again. Okay, so here, if you're selecting all the items, like if I have 12 items and I want to know how many different ways I can put them in order and only select each one once, if I have all of them, I just take like 12 factorial. If I take some of them and I'm putting them in order, this is NPR, okay? So that's where that one comes in. If order doesn't matter, this is NCR, okay? So how many different ways can I select like 5 items from the bin at all, right? It doesn't matter what order I select them in, is how many different ways can I do this? Now, an easy way to remember that combinations are the order doesn't matter and permutations are orders do matter is that your combination locks on a locker are actually misnamed. They should actually be called permutation locks. Why? Because you cannot put the numbers in the combination lock in the wrong order and hope that it would open. So in fact, those are permutations because the order that you put the numbers in the lock matter. So remember that the combination lock is misnamed and that when order matters, you have to use permutations, not combinations. Okay, if I don't have replacement and I'm picking R items out of N, I'm picking R items out of N, then each time I get the same value, right? So like if I'm going to pick 5 items, I can pick N the first time, N the second time, N the third, N the fourth, and the fifth. That's just like N to the 5th. So this one becomes N to the rth. It's just multiplying the same number over and over again. This box is not in this course, so you don't ever have to worry about that box. So this table is going to become somewhat relevant in the days to come in this class. So you might want to kind of keep this in a safe place and know how to use it. All right, thank you.